Welcome to this tutorial on NumPy's power operation. Today, we'll explore np.power, a powerful function for raising array elements to specified powers. This is an essential operation in scientific computing and data analysis. np.power is a NumPy function that raises each element in an array to a specified power. It performs element-wise exponentiation, meaning it applies the power operation to every individual element in your array, returning a new array with the results. The basic syntax is np.power with two parameters. The first parameter, x1, is your base array or scalar. The second parameter, x2, is the exponent array or scalar. The function returns a new array where each element of x1 is raised to the corresponding power in x2. Let's see a simple example. We create an array containing 2, 3, and 4. Then we use np.power to raise each element to the power of 2. The result is an array containing 4, 9, and 16. 2 squared is 4, 3 squared is 9, and 4 squared is 16. You can also use arrays as exponents. Here, we have a base array with 2, 3, and 4, and an exponents array with 1, 2, and 3. np.power pairs each base with its corresponding exponent. The result is 2 to the power 1 equals 2, 3 to the power 2 equals 9, and 4 to the power 3 equals 64. np.power supports broadcasting, which means it works seamlessly with multi-dimensional arrays. In this example, we have a 2x2 matrix. When we raise it to the power of 3, each element is cubed. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. NumPy provides an alternative to np.power, the double asterisk operator. Both approaches produce identical results. Using np.power offers explicit function syntax, while the double asterisk operator provides a more concise mathematical notation. Choose based on your coding style and readability preferences. Let's review the key points. np.power performs element-wise exponentiation on arrays. It supports broadcasting for different array shapes. It serves as an alternative to the double asterisk operator, and it works with both scalars and arrays, making it versatile for various mathematical operations in NumPy.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.